Okay, let me make sure this is recording. Yeah. Okay, so for number 48, we're trying to figure out when the tangent to f of x is a horizontal line. And one thing that we know, regardless of what f of x looks like, let's say that it looked like this. Well, in this case, we get a couple of horizontal tangent lines. And the one thing we know about horizontal lines is that the slope equals 0. So in our problem, we have this parabola. And so the parabola looks like this, and the slope is 0 right here. That's when the tangent line is 0, it has a slope of 0. And for a parabola, it's always going to occur at the vertex. And you might remember that the x-coordinate of the vertex is always negative b over 2a. And so that's negative 4 over 2 times 1, which is going to be negative 2. So we know that it occurs when x is negative 2, but really I want to be able to do this using the definition of slope that we came up with in class so that you can do it even if it's not a simple parabola. So let me erase this here. So off on the side here, I'm just going to put this over to the side. We know that it should be when x is negative 2. But we'll try and do this using what's really more complicated stuff, but it's using the ideas that we built up in this unit. So one thing is, so this is some parabola. And let's say that we want to figure out the slope when it's 0. Or we want to figure out when the slope is 0. So we do know that the slope at a point, a f of a, well, actually, yeah, let's say a f of a, and the point a plus h, f of a plus h, so a little bit off to the side, that slope is going to be f of a plus h minus f of a all over h. And if I make h turn into 0, then this point right here gets closer and closer to my a f of a, and the slope of that secant line starts to turn into the slope of a tangent line instead. So if I throw limit as h goes to 0 in front, this right here is the slope of f at x equals a. And what we want is we want that slope to equal 0. Okay, so let's work this out. So the limit as h goes to 0, and f of a plus h, that means that the x is a plus h, so it's a plus h squared plus 4 times a plus h minus 1. So this becomes here, a plus h squared plus 4a plus h minus 1 minus f of a, which is a squared plus 4a minus 1 all over h. And we want that to be 0 still, right? So if I work this out a little bit more, limit as h goes to 0 of a squared plus 2ah plus h squared plus 4a plus 4h minus 1. And then I'm going to distribute the negative minus a squared minus 4a plus 1 all over h. That has to equal 0 because we still want that slope to be 0. Okay, so we can cancel some stuff, and really every term that doesn't have an h in it ought to cancel. So a squared and negative a squared, 4a and negative 4a, negative 1 and positive 1. So what I'm left with now is limit as h goes to 0 of, and I'm only left with h terms here. So what I'm going to do is I'm going to factor out an h. So I get 2a plus h plus 4 all over h. And at this point, I can cancel my h's that are floating around there. This still has to equal 0. And now I can actually plug in the h equals 0 right here, so I end up with 2a plus 0 plus 4 has to equal 0. So 2a plus 4 equals 0. So 2a equals negative 4. So a equals negative 2. So what we know is, we know that the slope of f at x equals a is 0, when a is negative 2. So that's another way of saying that. Let me shrink this down a little bit. So another way of combining these two statements into one statement would be the slope of f at x equals a, but a is negative 2, is 0. Let me use the number 0. Okay. So let's see, what can we do with that? So we know that the slope is 0 when x is negative 2, and that verifies what we set up here. Whoa, okay. There, what we set up here. And then let's get the y value too. So f of negative 2 is going to be negative 2 squared plus 4 times negative 2 minus 1. So that's going to be 4 minus 8 minus 1, so negative 5. So let's see. This means that at the point negative 2, negative 5, f of x has a slope of 0. And remember, slope of 0 means the same thing as it has a horizontal tangent. And since that's the only a that we could solve for, the only x value that I could solve for when I set the slope equal to 0, that's the only time that you get a slope of 0. Otherwise, we'd have like a equals negative 2 or a equals something else too. And that would have shown up in these calculations here. Okay, I hope that helps.